Hello, everyone. A very good evening to all of you. I'm Bhavti Doshi, Marketing and Branding Head at Minimac Systems Private Limited. Thank you so much for taking out time and efforts and coming to this webinar. Today's webinar, we are going to talk about hydraulic systems and best maintenance strategies and practices. How you could save a lot of downtime cost and increase an overall profitability for your respective plans. Today we have on the panel Mr. Anshuman Agrawal and Mr. Yogesh Kumar. And I'll just brief you up on how the flow of the presentation is going to be. I would like to welcome all the speakers on board. And today's flow of the presentation is going to be the same, how it has been in the past. We are going to talk about hydraulic systems, the issues, the problems that comes along with it. If the oil is not maintained well, if the contamination control is not controlled and taken care of nicely. And later on, we will open the forum for Q&A. Please make sure you drop in your questions in the Q&A. When you tap your screen, you'll be able to see a Q&A box which is separate from the chat box. So make sure you drop in your questions in the Q&A box so that we don't miss out any questions that are important to us. And post that, I will let you know how and what platforms are there where you can follow us, you can register for upcoming webinars, and how you can get into a community of lubrication reliability professionals that we have globally. To not miss out any updates and stay, right on point with your knowledge and awareness related to this particular topic. So let me welcome Mr. Yogesh Kumar to start the presentation today. Let's make it an interactive one. We will have some poll questions in between.
Thank you, Bhavti, for the nice introduction. Welcome, everyone. Good morning, good afternoon, and good evening, based on the continents. Mr. Anshuman, can I have a full screen presentation, please?
Yes, it is already on full screen, sir. You can start.
Yeah. Thank you. Yeah, so we will see today that how to maintain hydraulic system. Before that, we can see that nowadays hydraulic is taking over the mechanical transmission component or mechanism. How and why we will see on the upcoming slides that hydraulic is popular nowadays and becoming popular fastly due to its simplicity and high capability. Like it has very less number of linkages, hinge joints, chain mechanism, drive shaft, and other mechanical components which are required to transmit the force from generating point to the sink point or to the actuator. And when it comes to a zigzag path or a very large distance when we have to transmit the force or power, then certainly due to linkages, wear out, looseness, or long distance, we have transmission losses. In few cases like belt drives and other, we can see that losses is more than 22%. So when we switch to hydraulic system, we find it very compact, very less sophisticated, and easy to maintain. The loss of power is almost negligible. We can transmit more than 99.9% of the power from source to sink. So we will see how hydraulic system is transmitting power. Here we can see a simple example that force is applied over a piston and it tries to compress the fluid below it. And when the fluid is compressed, pressure will increase and that pressure will transmit to the piston number 2 and it will try to lift the piston 2. So in this picture we can say both the piston are of the same size, So the force applied at the piston 1 is getting transmitted to piston 2. But if we change the diameter of the piston, then what we learn in our basics, that pressure into area is equal to force. So suppose we increase the piston to surface area, then whatever force we are applying on the piston 1 will get multiplied with the factor of area increment, and resultant force will be very very high than the applied force. Then the next advantage is very precise control, because we can control the movement of first piston, and by that the same force or same power will get transmitted to the piston 2 without any wear component or linkages in between. So we don't have to calculate the transmission losses here. So how much output power will be, accordingly we have to adjust our input power. It is not the case of hydraulic. It is easily controllable manually or automatically. When we talk about the terms of power, we can transmit huge power, because oil or any fluid which is used in the hydraulic circuit uh, can sustain enormous pressure, and there is no harm on the fluid or on the media because of pressure. So there is no limitation for the transmission, or we can say power transmission. And reliability of this system compared to normal link based mechanical system is very very high, because wear tear or rotating components are very very less. Just we need a small source of power, that may be pump or actuator. After that, the liquid itself works as linkages, joint, hinges, rivets, whatever component we can name them. So we will see in detail in upcoming slides. Yeah, so it's time for a poll question. Uh, Further going in depth for the hydraulic system, just you have to answer that hydraulic system works on which law, whether it is Charles law, Pascal law, Boyle's law, or all of the above. Because all these three laws are related to pressure, temperature, volume. So for a hydraulic system, which law is applicable?
I think the poll answers are already coming populated on the chat box. We can check
Uh,
the responses out there.
mm, so if we can vote on this radio button, then it will be easy to see the percentage. Hydraulic system works on one basic law. Mr. Charles Given, or Mr. Pascal, or Mr. Boyle. So awesome. 75% voting goes to Pascal law, and Mr. Pascal is the winner. Rightly said, the basic law which is applicable to hydraulic is Pascal's law. Later on, Charles and Boyle's law have certain application in the field of robotics, but they are not the fundamental law for hydraulics. Yeah.
Thank you so much, Mr. Yogesh, for giving that enlightening academic information of the hydraulic systems. So if we carry this information and we move ahead, and we would like to understand what are the various applications in the industries. I understand our audience is a very versatile one, and we would have people from multiple industrial sectors, multiple plants. So we have actually listed down certain applications where hydraulics is used in the industry. So first one is machine tool applications. So where we have various CNC equipment, we have lathe machines, and we have various robotic applications. So hydraulic finds a way in all of these. So if we see the picture and the text mentioned there, we have cutting, grinding, drilling, boring, and foaming. These are the various applications of CNC tools which are there in the industry. It can be for the automobile industry, or it can be for robotic industry, or electronic industry, or wire rotary industry, or even sling industry. So wherever you have any CNC equipment or a lathe, an engineering tool or machine tool, you would find hydraulics there. The purpose of hydraulics can be either clamping device hydraulics, or precision measurement of certain movement of the parts, or even if the cutting tool is being controlled, it can be with the hydraulic application if it has to be quite precise. So as we learned earlier, precision is one of the key parameters of a hydraulic system, due to which it is used in machine tool applications. Going to the next application, that's the hydraulic press and the shaping application. As the name suggests, it's a hydraulic press where you large amount of force on the particular job. The pictures what we can see here are of quite small sized presses, but we know that in the automobile industry, in the metal forming industry, there are very heavy presses to the tune of 10,000 ton capacity. So that's the capacity, or that's the force at which the press would come onto the job sheet, and that job sheet would be formed into a certain part. So if it a case of a trim plant in automobile industry, or any other company where you require certain forming of the metal sheets, hydraulic presses find their way. So hydraulic presses is something which you can find in automobiles, in metal industries, in engineering sector, and these are used for pressing application of sheets. These are used for cutting of sheets and other metal components. For punching, if you have certain application of punching, these can be small sized holes, or it can be a boring application, and also the forming application. So for all these applications, hydraulic press and shaper equipments are required. And here the hydraulic finds its way because of the large amount of force that it can pass on onto the job, and also because of the precision, the exact amount of force that it has to pass, it will certainly be able to do that. Now, as we understand in these two applications of precision and high pressure or high force application, so thereby there are certain issues or concerns of a hydraulic system, and those will be discussed in the future slides. Material handling equipment. Now, material handling is a very vast topic, and almost all the industries would have certain equipment for material handling. If we talk about the metal industry, so in a metal industry, there are equipment like forklifts, there are cranes, EOT cranes, and hoists. So elevators are there. So these can be used for material handling. If you talk about a power plant, so there you have bulk handling equipment, and these bulk handling equipment are in the place of coal handling. So there you have multiple equipment for handling of coal, for example, the wagon tippler or the sidearm charger or stacker reclaimer. So all these equipment also work on hydraulic principles, and complete systems are hydraulics. The reason is hydraulic can handle precise motion, as well as it can handle large amount of force when you have to provide certain motion. So these motion can be rotary, there can be linear motion, and there can be partial rotary motion like an actuator. So you have all the equipment which require various types of motions, and these motions are generated by hydraulic systems. Coming to the next part of application, it's the construction and the mining industry. And in construction and mining industry, it's not just handling of the bulk, but also at times excavation of the bulk. And that is what is required in terms of mining and construction. For example, you can see the picture of excavator, and I'm sure all of us would have seen it working on the roadside or on our projects, or if some of us belong to the mining industry, we might have seen it in the open cast mines or the underground mines, where hydraulic pistons, which are quite easily seen on these equipment will have cylinders and pistons which work on hydraulic principles, and they would pass on not just motion but also high amount of force for doing the job or doing the task. So the purpose for hydraulics is excavation equipment, lifting equipment. Then there are multiple pumps, which are very high capacity pumps, high pressure pumps, and these pumps require a drive, which need to be a hydraulic drive. It cannot work on electric drive mostly. So there you find application of hydraulic motors in these applications. For transporting, you have dumpers and dump trucks, where the dumping arrangement is all hydraulics. Then there is compaction of the roads, either temporary roads of a mine or open cast mine, or it can be a permanent road. So compaction purpose as well, because again, there is a force requirement. So for all these purposes, hydraulics finds its application. A few of the names of the equipment which we know of, they use hydraulics are excavators, cranes, dozers, loaders, dumpers, tippers. So multiple names, but the principle of operation lies the same. That's hydraulics in all of them. Next application is aerospace or shipping or railways. So in all these applications, you can say they are transportation applications, where either movement of passengers or goods is going to happen. So aerospace, shipping, and railway, they all come under the transportation applications. And in transportation applications, the important is the aerospace. So in aerospace, the entire operation of a flight of an aeroplane, it depends on hydraulics, not just the maneuvering, but also the wings and tails, the ejection system, the braking system, and in the jets of the fighter planes, everywhere you will find hydraulics. In railways, there are again braking systems which work on hydraulics. There are also certain damping systems, shock absorber systems. There you find hydraulics. In case of shipping, the entire steering motion of a ship depends on hydraulics. If we extend the shipping towards offshore industry, where you have offshore platforms. So on an offshore platform, there are multiple applications of hydraulics, where the stability of a platform, the anchoring of a platform, and the steering of a platform, everything depends on hydraulic systems. So time for another poll question. Which hydraulic component? You might have worked with multiple hydraulic equipment systems. So if you are a maintenance engineer or maybe someone who has been related to hydraulic systems, you can certainly give your opinion about which hydraulic pump or actuator or control valve or hydraulic motor troubles you the most. Please go ahead with your selection of the option so that we can understand what is the opinion of the audience out here. Another few seconds to close the poll before we get the responses in terms of percentages. Yeah, so it's a mixed opinion, I must say. 39% goes to hydraulic pumps, 19% goes to actuators, 36% to control valves, that again a big number, and 7% hydraulic motors. Well, it's quite appreciated because hydraulic motors finds a very limited application. Only few handling equipment require hydraulic motors. Hydraulic pumps, they are the common component on almost all the hydraulic systems, and all the hydrodynamic systems would require hydraulic pump. So thereby, yes, that's certainly one of the most important key components where you find the troubles. So in order to understand what are the troubles which we are facing, we would take the next few slides, and I would request my colleague, Mr. Yogesh, to explain a hydraulic system and also to explain what are the various troubles which he himself as a field engineer has faced in his life.
Thank you, Mr. Anshuman, for showing the application at real ground level. And now we will enter into uh, circuitry side of the hydraulics. So here we can see that there is a basic circuit for one hydraulic mechanism, and few basic components are mentioned here. So the component what we saw in the poll result causes much trouble is first is hydraulic motor, the very first component. Uh, if we see in this diagram itself, we have not mentioned any suction filter here before the pump or suction strainer. The very first mistake we do in our hydraulic circuit. Any media or oil entering into pump should be very clean, because hydraulic pump has to generate huge pressure uh, with its very tiny either rotary gears or piston cylinders, and there are very fine clearances in the pump. So any contamination, solid contamination, or whether this is moisture, or we can say water contamination, both damages the fine clearances and mating surfaces badly, and deteriorates the performance of pump very quickly. If we maintain the oil quality, then these pumps will last for years and years, because these pumps are designed not to have any metal to metal contact during their operation. So if there is not metal to metal contact, there is a very less chance to get wear out of a component. But contamination will break the film, metal to metal contact will happen, and they will damage the pump. Uh, to maintain the system pressure, we have PRV. These PRV are needle type mostly. So they have very precise opening to drain the excess quantity of oil to maintain the system pressure. So when this PRV acts due to high pressure, supersonic velocity is generated at the outlet of needles, and a very fine particle size of 5 or 10 micron is sufficient to erode the seating area of the needle, or we can say the plug area, because of high velocity, not due to its weight or size. So this supersonic velocity we cannot avoid due to precision requirement of this circuit. So again, contamination plays role to kill our PRV function. They will keep on draining the oil even if system pressure is not above the requirement. Then flow control valve, these are mostly throttling valves. And whenever we are narrowing the passage for a liquid to flow, the liquid velocity will increase due to nozzle effect. And is high velocity mixed with any solid contaminant is biggest culprit for a hydraulic system. Now oil enters into cylinder arrangement where we have seals, and when piston does to and fro motion, the contaminants stick on the cylinder surface or cylinder liner, we call them normally. They causes small scratches on the liner or inner surface of the cylinder, as well as piston seals. So in due course of operation, surface will get rough, piston seal will get worn out, and the performance of the cylinder will come down. Instead of sealing the oil, they will start leakages or passing of the media, and later on we will come up with failure of the entire system. One very important component for the hydraulic system is direction control valves. They may be three envelope four port, or two envelope four port, or 5x3 type, 4x3 type. There are various names based on their configuration and inlet outlet ports. So whatever configuration is there, basically one spool will be used having very fine clearances with its body. Spool will move to and fro from envelope to envelope to give oil different directions so that we can get our required actuation of the cylinder or of the hydraulic motor. So these direction control valve can be control manually or with magnetic coils, or sometimes spring loaded with single coil. So external mechanism may be different. Internally, every DCV will remain the same. One spool and one body. Now, for a precise control and smooth operation, we need a minimum gap between spool surface and body. Sometimes they are in the range of zero point 0.5 micron or 1 micron. So suppose our oil is very pure, what we call NAS 5 class. Still we have particles in oil in the range of 5 to 15 micron or 15 to 25 micron. Those particles, when they enter into fine clearances, they will again damage the spool, damage the body. Sometimes they will lead to sluggish operation of the valve, or sometimes complete stuck up of the valve during opening or closing. We will see a few more application. Mm, so now coming to our basics again, what is the role of fluid? It is not just to transmit the power, but at the same time, it act as coolant, it acts as uh, contamination removal agent, sealing body, lubrication. Suppose we take an example for this direction control valve. Since it is operated by solenoid coil, so in due course of operation, it will get heated. The oil passing through this valve will take away the heat. Then any foreign particle sticking on the body or on the spool, they will get washed out by the hydraulic oil or fluid. Then sealing, it will come how fluid will act as sealing. Whenever there is fine gap and high pressure gas is inside, like our application of generator, these fluids are also acts as sealing agent between atmosphere and the gases available inside the generator. Normally it is hydrogen. It is like air curtains we see on the shopping mall gate to isolate the atmospheric air from the air condition system inside the mall. It is the same application. Then movement of spool, there should not be rubbing, so it acts as lubricant. And finally, the main purpose is the transmission of power from source to the desired component. Uh, uh, so when we talk about the hydraulic, we see that we are using oil or any fluid. So there are hundreds or thousands of different fluids available around us. Which fluid is suitable for a particular application? How to judge it? The same fluid cannot be used for the coal handling plant or for the turbine governing system, because application and property required at both the places are different. One is working in very dusty environment, and for the bulk handling, their transmission of huge power is primemost criteria. Whether if we are talking about the governing system, then precise control or very fine tuned operation is required. So how to select the oil? First, oil should be incompressible, whatever the hydraulic application is, because incompressible oil can transmit maximum of the power gained from the source. If it is compressible, then part of power will be used to get it compressed, and ultimate output will be lesser than the input. Then good lubrication capability, what we discussed in the last slide, that it should have enough lubrication property to avoid any surface rubbing, or it has sufficient lubrication property to make or form a film between two moving surfaces. It has to carry away the heat, so it should have good heat dissipation capacity, because it has to absorb heat very quickly, and as soon as it enters into the heat exchangers or cooler, it has dissipate the heat, release the heat. So both the properties it should have. Then foam is one of the big enemy for a hydraulic system. Foam contains air. Air is compressible, so we lose the incompressibility of the fluid when foaming is there. Then when foam enters into high pressure zone, it will rupture or it will burst. Bursting will cause micro drizzling effect, cavitation, pitting. Sometime it will promote the galling effect if it enters into small cracks. Oil should have sufficient quality to demulsify. Emulsification is mixing of water with the oil or mixing of gases in few cases. So even if water enters into the oil should have property to get separated from the water, and due to density difference, water will settle down into the bottom in most of the cases. And if a specific gravity is high, then water will settle on the top of the oil. In both the cases, that water is not going to enter into the circuit if oil is demulsified properly. Then we cannot keep our hydraulic system in a very safe place or within closed area. Always it has to work in the field, so it should be robust enough to handle different weather condition or tropical situation. It has to work under the rain or high heat, high sun, or sometime temperature below 0 degrees Celsius or minus. So all these properties we should see carefully when we select the hydraulic oil for our application. Yeah. Uh, Factors for selection of hydraulic fluid we have discussed in the previous slide, and we try to summarize it here. Um, like operating pressure of the system. Operating pressure of the system is again related with demulsibility of the oil, and capability of oil to handle the uh, foam. So we should have sufficient anti-foaming agent or defoaming components. Then compatibility of the oil. If oil is not compatible with its application side, that may be seals, hoses, valve. Suppose if we talk about the phosphate ester oil, they are very reactive in nature. Normal butyl rubber or NBR will get dissolved into it. So we have to see what type of components uh, we have in our hydraulic system. Accordingly, we can choose the oil, and we can select the chemical property of the oil. Then one most important part comes when we talk about the economy of hydraulics. So if we choose a oil having very good property in every aspect and the cost of the oil is very very high, then we have to compare with the next oil which may have one or two property lesser than the best oil, but that oil is suitable for our budget. So after a few hours of operation or few years of operation, we can go for the oil replacement that may be cost effective for that particular case. Again, when we choose the fluid, we have to say what type of contamination may come. Suppose we are working in the refinery where air has a lot of gases, hydrocarbons. If we are working in the mining area, we have uh, much of carbon dust around the equipment. So based on the working environment, we have to choose the oil. Which oil will not lose its properties due to these contaminants. We will see few more application which will focus on the selection of lubricant. Uh, Now coming to maintenance side of hydraulic circuit. Hydraulic circuit can run for years trouble free with only one solution if we can control the contamination in the hydraulic fluid. Hydraulic circuits are mostly closed loop circuit. So there is very few chance. So external contamination or external air will come in contact with the oil during operation. But what about the tank? Since quantity of oil running into the circuit, or we call it circulation, oil in circulation. This quantity varies based on our control or command. Sometimes more quantity of oil is out of the tank, or sometimes returns back to the tank. So tank level fluctuates always. And above the oil surface in the tank, we have some empty space called uh, header space for the oil. It contains air. So whenever oil level goes up, air will come out. Whenever oil level goes down, air will come in. We call it breathing of the tank. Tank exhales and inhales the air. So whenever it inhales the air, it will take contaminants from ambience or surrounding air, and the air comes in contact with the oil top surface. Oil has a tendency to absorb moisture or to dissolve the contaminants into it. So in the process of breathing, continuation is there for the contamination addition. Now, what to do for that? we can put a very good breather, and how to see the performance of the breather or of the system, that is sampling. Now, before testing the oil, a good sampling method is very vital. A wrong sample will give wrong indication, and it will disturb the entire maintenance plan or shutdown plan. If we take sample from the bottom, we have marked here with the red dot, those sampling points are not advisable at all, because heavy contaminants will settle at the bottom, water will settle at the bottom. So sample will not give you exact condition of the oil. So it is good to take sample from the return line. Return line indicates that what is the condition of the oil running into the system. Then the question come, we can take from the supply line. Very good, we can take. Supply line sample will not give information about the wear occurring in the hydraulic circuit. Suppose there is some rubbing in the hydraulic cylinder or hydraulic motor. There is some metallic wear out or seal wear out, non-metallic particles. Those all will come back to the tank via return line. And when we take sample from the return line, and when we do for the elemental analysis or ferrography, wear debris analysis, they will give us very prior information that which component is going to fail and what is the rate of wear out or extent of damage, or how rapid we have to take action to maintain that component, and what we should do immediately to remove those particles from the oil. That may be our internal purification system, or the most recommended kidney loop system, where we are not going to disturb the running system and externally we clean the oil up to the extent what is recommended by the manufacturer, or by the experience what we gain, what cleanness level we have to get. get. Uh, we can see some real-time pictures. When we visit the industry, we see the condition of breather. Normally, breathers are most neglected part of the hydraulic system in general practice, but they are very critical component, and they are vital for the contamination control in the hydraulic circuit. Breathers can be silica filled with fine membranes to stop both water contamination as and solid contamination. Then when we see circuits, we find few leakages, and we found that leakage or spillage of the oil is collected in some bucket or jar, and it is filled back to the tank. The oil collected in the jar is highly contaminated and very, very dangerous for the system. That oil can be reused after collection. If we have sufficient quantity, we can filter them out externally. After testing all the parameter, we can use them as our top-up oil. And irony is the filtration system. Sometime we fail to understand the actual requirement of our hydraulic system, because when we talk about the oil purification system, it has so many types and so many parameters within it. So selection of these are just like selection of medicine by a doctor. Chemist can suggest some medicine, but that's not the proper solution. So we have seen that for a bigger tank, few machine are installed with model number having four digit, five digit. So it is misconception that model number with like 1000 or 1500 showing that the system is capable to handle large volume of the oil. No, that is just I washed, or maybe some specific reason they have given the large number. Any purification system, we should check the flow rate of the pump. That will give the true picture of the flow rate. Next one is the filter used in the system. What is the surface area of the filter, or what is the designed volume flow rate across the system. Suppose we have 20 LPM pump and the filter is designed for 10 LPM, then the excess quantity of the fluid will push the contaminants back into the system, because that filter has no capacity to hold sufficient quantity of dust with the higher flow. Then third point will be dirt holding capacity, then bypass mechanism. So whenever we select our filtration system, we should see the requirement of the system, the oil volume, the ingress rate of the contaminant. Suppose we have a tank of 100 kl, it is totally sealed, breather is very proper, then we may not require very large size system to purify even 100 kl of oil. But for the 10 kl system and contamination rate is high, so the removal system should be capable enough to take all the contaminant out of the oil. So selection of the purification machine is a different subject, and someday we will talk on this in detail. Uh, when coming to troubleshooting part, we face in our day-to-day maintenance activities. In the hydraulic system, troubleshooting is very limited because of its limited components or limited type of component. So just 10, 12 points are there, and we can say 90% or more than that of the issues comes only within those points. There may be some specific trouble sometime somewhere. Those are exceptional. But like motor is tripping frequently, or motor is not discharging the liquid, delivering the liquid, then cavitation, excessive vibration and noise, we can relate all these problems with uh, only two parts. One is what the input we are giving, that is our fluid, and where the fluid is exposed. Suppose the fluid was or our system was designed for a temperature around 65 70 degrees Celsius, and if it is exposed to 100 degrees Celsius, definitely problem will come. So those are events, one in blue moon. No, normally when we see motor is tripping, means there is high discharge pressure or insufficient suction pressure. Either suction external got choked, or discharge filter got choked, or motor is overloaded due to continuous draining of fluid from PRV or FCV. PRV is malfunctioning, cause will be again contamination. If FCV got worn out, cause will be contamination. Suction pressure or suction extender got choked, discharge filter got choked. Everywhere you can see contamination is playing the role. Excessive power demand, again draining of the liquid, excessive wear and heat, solid contamination, and few cases moisture contamination also causes heat due to bubble rupture. cavitation is nothing but due to foaming. So all these issues can be addressed well in advance if we can address the quality of the working fluid by proper sampling, proper testing, and proper reconditioning method. It's time for one more poll question. Which problem is faced by you the most? Please participate. Uh, so we will see, and in our upcoming webinar, we will try to address those areas uh, more which are causing trouble to us. So we can say that valve is failing to open or close, leakage through valves or PRVs, excessive pressure drop, or open close is too fast or too slow. Yeah. So it is again mixed response, but failure of open closure of the valve and leakage through valve are the main area causing trouble to us. And okay, we will see those troublesome areas and how to overcome those area. So here we have just tabulated issues with the reason, and you can see that for failure of the valve open close, most of the issues will play the role, like dust, debris that is caused by contamination. They may also cause silting on the moving spools. Excessive wear will caused by both solid contamination as well as water contamination. Gailing is nothing but uh, damage of component, or sometime it is uh, peeling off the top surface. This may be sometime due to subsurface cracks, but when these moisture content oil enters in those area and during high pressure, they burst and they chip out the top layer. Then line pressure too high, we just discussed. Thread and solenoid fail. How contamination is causing thread failure or solenoid failure? Solenoids have a tendency, whenever we magnetize them, they will either pull the plunger or they will try to push the plunger. If plunger movement is seized or locked or very sluggish, the coil will keep energized for longer duration and they will get overheated and fail. Mechanical damage, corrosion, valve undersized, sometimes it happens because if valve having no factor of safety like 1.5 or 2, then very small contaminant or very small damage to the valve will lead to in operation of the valve. I would request Mr. Anshuman to take it further.
Thank you so much, Mr. Yogesh, for that detailed analysis of hydraulic systems. And I'm sure the audience would have liked the grassroots level of explanation for various problems, causes, and all the reasons which are involved in the day-to-day life of a hydraulic maintenance engineer. Now, coming to the next part of this, how oil or the hydraulic fluid, it is impacted because of various contamination and how it is linked to the total revenue loss in a plant which is having too much dependency on hydraulic systems. So we have understood that hydraulic oil certainly plays a major role in any hydraulic system. And of course, to maintain the property of the hydraulic system, we must take care of various purification and filtration related activities. We have been discussing on this topic in our previous webinars also, where we have not just talked about hydraulics, but in a whole, the lubrication oil. So even in the hydraulic systems, the degradation of the hydraulic oil, it can lead to formation of acids. The hydraulic oil might be the naturally found mineral based oil, or it can be a synthetically processed hydraulic fluid. For example, it can be a water glycol fluid, or it can be a phosphate ester or EH fluid. So many names to the synthetic type of hydraulic fluids. All of these will degrade and they would form total acid number increase, which happens because of formation of acids. We have been discussing on formation of acids in hydraulic systems in past webinars also. Now, due to these acid formation, there would be a complete loss of failure of the valves, especially the critical ones, which are very costly as well, like the servo valves or the move valves. Or even if they don't fail, there would be some symptoms of valve hunting, which would ultimately lead to the sluggish behavior of your entire hydraulic system. For example, if you are having a hydraulic press and it is supposed to function at 210 bar, but there is a problem with the particular valve, the relief valve after the pump, which maintains the pressure of 210 bar. Suppose there is a problem of that valve, there is a contamination in it, and the valve is not functioning. There would be an entire loss of pressure. There would be a complete loss of the force which you want to apply on your job. And ultimately, that hydraulic press would not deliver you the right quality of product. Either it would be stuck up or it would be delivering a wrong ultimate job for you. Take an example of a wagon tippler, which tupples the entire bulk material of coal or some other mineral. And the function depends on the movement of a hydraulic motor. Now, this hydraulic motor gets its high pressure hydraulics from a particular valve. And if the entire line components, they fail, then probably your tippler would be stuck in a position where you can't either unload it, nor you can move the rack rail from out there. So it might lead to time loss for you. It might lead to production loss for you. It might lead to the entire operational inefficiency for you. So a sluggish behavior of your hydraulic systems, it can certainly cause a lot of unplanned shutdowns. It can cause equipment efficiency loss, and thereby loss of revenue for your plant or your department. So where the improvement is needed, almost all the aspects, but the first improvement is needed in the way how you handle your hydraulic systems. So the lubrication handling starts right from the area where you have stored the lubricant. So you must start introspecting whether you have got the right tools and tackles to maintain the handling devices at your lube cell. Do you have a separate team or a separate cell which is capable enough to handle the incoming lubricant, to fill up the lubricant into your equipment or not? Whether do you have a cell or a condition monitoring unit which can actually sample the lubricant in a proper fashion and not just in a ad hoc fashion or a non-professional fashion? Are they doing the analysis in a proper way? And of course, you need a team or an effort towards doing the entire assessment of how hydraulics is being handled in your plant, how it can be improved. So certainly you require reliability improvement through lube assessment. So such kind of a program is available, and you can certainly contact us back if you would really like to do something about the way how hydraulics is being handled at your end. Now, we all have heard a lot of times that 70 to 80% of hydraulic system failures, it can be traced to the contamination present in the hydraulic systems. And in order to handle that additional contamination which is upgrade your hydraulic systems, you need to have certain elements in your program. And those elements are a proper purification machine or filtration machine or a contamination control program. Second, you need to have assessment of your installed filters. Many times we depend upon the choice of the OEM of our hydraulic system. But it's very important to understand that the OEMs of hydraulic systems are governed by multiple strategies before they do a selection or a technical selection for filters. And there are limitations on a particular hydraulic system where you cannot go for highly efficient filter arrangements. So in order to go for efficient filtration arrangements, you might have to do some retrofitment with your hydraulic systems. You can certainly not depend on the offered filters from your OEM side because they are the bare minimum basic filters or the filtration arrangements on the hydraulic system. So that certainly calls for a need where you need to go for finer filters, super efficient filters, which can maintain for you a super clean oil. Oil analysis program. Without we knowing on what is the condition of our oil in terms of parameters, well-defined standard global parameters, we would be in an ostrich situation where we would not be able to understand that our oil is really contaminated. And hence we need to establish a well-defined global standard followed oil analysis practice. This can be either done in-house or you could follow an external lab who can do the testing and analysis for your requirement. The technical consultancy. So of course, if you have a team who is well aware of system maintenance, then you could form a special task force who can, in a neutral fashion, provide you a consultancy towards hydraulic system improvement. But in case you require a professional approach and also an approach which industrial standards and the global standards, then you need to go for external auditors for the lube assessment. And for these requirements, the Minimac sales team can be approached at any juncture who can help you with all these 4 offerings and help you out in your pursuit towards ideal hydraulic system. There are certain checkpoints which we always leave out with our audience before signing off. So these are the checkpoints which you can follow. I'm sure many of you would be having it on the maintenance, daily maintenance list, but just in order to remind it to those who might require these. So you need to check the fluid level. You need to check the condition of the hydraulic filter. By checking the condition of the hydraulic filter, we mean to say the DP values or differential pressure values. Here you need to understand that many times these DP gauges don't function because they themselves get choked. So you have to check whether they are working or not. And if yes, the filters are choked up, you need to change them. Filters are not there to last long as life goes. Filters are there to change, and filters are there to save us. That's why the name in many countries, they call it as a monitor and not just a filter, because they are there to check our contamination. And if they don't function or if they have got choked up, you're still using them, then basically you are just making them redundant and you're not serving the purpose. So changing the filters should not be a burden for you. It should be rather a happy activity, because if the filters have got clogged, you must have a feeling that, yay, I got my contamination trapped in the filters, and those contamination which have choked my filter are not present in my system anymore. So you should actually feel good about it and not rather find a headache in changing the filters. Obtain the fluid sample properly and send it out for testing, either in your lab or in the external lab. Clean the inside and outside of the reservoir so that you have a neat and tidy environment. Follow 5S whenever you do any maintenance activity. Check the records of hydraulic pressure, because this would certainly be a part of your quality program as well. If the hydraulic pressure is not maintained, probably your end use or end job would not be sufficiently good enough. Check and record the pump flow rate, because if the pump flow rate is going down, there would be certain reasons to it. Check the hydraulic hoses. Hydraulic hoses are again consumables. They don't last long than as good as a life. So they would be a consumable. And if hydraulic hoses are failing, they have leakages that can lead to plant level accidents, because hydraulic systems work at a pressure which is much, much above a pressure which can actually punch a hole in a human body. So a hydraulic hose failing and your persons or manpower working around that hydraulic system, that's a really very dangerous situation. And hydraulics hoses must be changed whenever you find slight damage in the hose, a slight leakages coming out of the hose. You should immediately check the crimping point of those hydraulic hoses. Either you change the hose or you at least change the crimp. The tubes, the fittings, everything must be checked for leakages. You need to check the amperage on the main pump motor, because that would be one of the initial indicators which would let you know about the overloading on your pump. And if there is overloading on your pump, it means the pressure gauge or the pressure sensor are probably not working. So thereby, if you check the amperage on your main pump motor, you would come to know what is going around with your hydraulic pump. So signing off with this presentation, with this short checklist for all you guys and all you hydraulic experts. Thank you so much. Over to you, Bhavti. You can handle the further proceedings of this webinar.
Thank you so much, Mr. Anshuman and Mr. Yogesh. That was a wonderful presentation. And now we will open the platform for Q&A. There are many questions already awaited. So quickly, if you have any situation, any issue that you're facing with respect to hydraulic systems, kindly drop in your question in the Q&A box. And we have our upcoming webinar on my very favorite topic, which is flushing. So we are not just going to talk about flushing, but we are going to talk about how you can achieve successful flushing in lesser time. And that's a very important topic to talk about. It's going to help many systems and how different contaminations, diameters, different sizes of pipelines, all the cavities, how it could be removed, and furthermore on flushings. We will also talk about real-time success stories and experiences, how we have helped certain industries and plants save billions of dollars due to flushing. So we will look forward to see you again on 25th. We have the registration link in the chat box. So kindly make sure you register soon to receive the joining link on your email ID. And in case of any other query, you can reach out to us through our website and email, which is info@minimac.in and minimacsystems.com. Now we would start the Q&A. So I would request the speakers to unmute themselves. Let's start. The very first question we have is from Mr. Chaudhary, who wants to know what are the reasons for rate increasing of TAN of phosphate ester oil?
Okay. It must be rapid rate of, yeah. So, Mr. Anshuman, would you like to take this question?
Yeah, phosphate ester fluids is certainly a very key area in a power plant, and these are used for the control system application. And increase of TAN is linked to multiple reasons, but the key reason behind it is the degradation of the hydraulic fluid. The degradation happens because of presence of contamination. The presence of contamination can be moisture, metal particles, and you can detect them using tests. You have got water tests like the moisture analysis test. You have the NAS class test, which is the solid particulate distribution test. So you can perform the contamination measurements. From there, you can understand what is the level of contamination and the reason why the oil is getting degraded. This topic we have done earlier, a full webinar on phosphate esters. I believe it was in the month of February. So if the admin can share the link of that webinar with the gentleman, I think a lot of his questions can be answered. And a point before going on to the next question, that phosphate ester acid values can actually create havoc in your plant. If you have got control valves, they can fail and your entire turbine can go on a shutdown, unplanned shutdown. and your MOOC walls and server walls, they are very costly. So you can land up losing around 7 to 8 MOOC walls or server walls just because of this TAN value increase. So if that is troubling you in your plant, I think it's the right time you get back to us, get us and we can certainly solve your problem of TAN increase in the phosphate ester. There are instances which we have discussed in past where TAN values from 3.0 have been brought down to levels of less than 0.15. So that's a huge decrement which has happened. 20 times lesser TAN values have been brought in. So you can certainly get back to us.
Thank you so much for that detailed answer. The next question is from Satya Prakash, and he's asking what types of filtration we do. I think he wants to know what kind of contamination we can help them with and remove.
Yeah, so I think here again, we have done one webinar on various contamination control techniques. So there, in short, I would explain to you as you have asked this question, we have mechanical filtration, we have electrostatic based separation technique, then there is a centrifugal based purification technique. In terms of removal of moisture, there is vacuum dehydration, there is centrifuging, and there is coalescer based removal. Also for moisture removal, there is filtration, which will have absorbing benefits also. So moisture can get more absorbed in the filter elements. So in all, there are some 7 to 8 various technologies which are used based on the application, based on the total volume of oil, based on the type of contamination which the client is facing. So as Mr. Yogesh had mentioned earlier, filtration is not a application or a solution which can be done in one stick doing all the solutions. It has to be based on a tailor-made solution. So if ever someone of this audience wants to go for purification, filtration, you must discuss in detail with your service provider or the solution provider. Only after that, you should go ahead with a procurement.
All right, thank you. The next one is from Akhil, and he's asking why mostly heavy machineries use hydraulics than pneumatics.
And during the presentation, one point was there that we have to check the property of hydraulic fluid. It should be incompressible because when the media is compressible like air, then part of the power uh, which we are giving to the fluid to get transmitted will get consumed just to compress it. And the second point is controlling of the system. When we go for the pneumatic, we have to build up certain pressure first, then the actuation will happen. And when we want to stop the actuation, it will not stop at that moment itself. But even we stop the giving extra power to air, the residual power of air will keep it pushing forward. So in case of hydraulic, we get control like our electric switch button on air and off type control. So any liquid which is incompressible in nature uh, can be used as hydraulic fluid, and Pascal's law is applicable only for incompressible fluid.
All right, thank you, sir. Let's go to the next one. Mr. Shailendra Shukla has a lot of issues and situations taking place in the plant. So we will answer a few of his questions. And sir, I would request you to get in touch with us in detail over the email ID shared. His first question is last year, they were facing water ingress in hydraulic power pack. They tried to find out every water source but couldn't. They have done water testing of heat exchangers, but it was found to be okay, no leakage. So, how can we help resolve it?
Nice question. And such situation we have encountered many times. It took us a long time to get the solution, but we have it now. And when we see or talk about the mixing of two different fluid, we simply see the differential pressure across the wall or media separating those fluid. In terms of heat exchanger, you have metal pipes or metal plates to separate oil and water. There is something called Gram's law of diffusion, and a second part of this is osmosis. So when we do the hydro test, there is single media available there, that is water or oil, anyone. So these both the laws are not applicable that time. So any chances of cross contamination will not happen there. But when you have liquid and water, both have different densities. So now the higher density liquid will try to move toward lower density liquid, and this is the reason we don't find any leakages or any point during our hydro test of the system. But when we take the system into operation, we find that our working fluid is getting contaminated. So to do this test, better to go for helium test of leakage detection. That will certainly help you.
All right, thank you so much. I hope Mr. Shukla has got some idea to how his query could be solved. He has a few more questions, but we will take up other ones and maybe reach out to him a little later with detailed discussion. The next one is from Lavani Vaire B, who wants to know what is the most important property in hydraulic oil analysis to determine drain time.
Mr. Ashwan. Uh,
By drain time, is it that the oil change time? What you mean? I'm
Yes,
assuming that,
yes.
right? So there is no as such any drain time for hydraulic fluid because you don't change the hydraulic fluid, and you don't have to change it actually, because hydraulic fluids have an indefinite life. I'm repeating it, hydraulic fluids have an indefinite life if you can actually maintain the contamination in the hydraulic fluids. So in order to do the perfect oil analysis, first of all you need to do the basic analysis, which is on a lesser frequency basis, like a weekly analysis of hydraulic oil. It can be your viscosity analysis, NAS level analysis, and water analysis. Then you have monthly analysis for hydraulic fluids, which can be a little advanced ones. For example, it can be acid checking analysis, or it can be oxidation level analysis. And if you want to have further detailed analysis, you can go for 6 monthly or annual basis analysis. It would include the additive level analysis, which can happen with your elemental based analysis using ICPs and spectrometers. And you can also go for FTIR based analysis. We had discussed in depth the analysis part of what analysis we should do on hydraulic systems and what we should do on lubrication system. So if you are certainly having a good analysis program, then you probably won't have any drain time or oil change time, because your oil has always been maintained. But if we have a complete absence of oil analysis, that is the area where we are not what is the condition, and that is why we change our hydraulic fluid. I hope this answers it in a logical fashion.
I hope certainly it does. We will take the last question of the evening, and that is from Mr. Alex. What kind of breathers desiccant with respect to microns should be installed in hydraulic system reservoir?
Selection of breather again requires certain inputs. Number one will be the purity level required. Suppose if you want that there should not be any solid contaminant more than 5 micron, then your membrane of the breather should be capable enough to stop any particle which is bigger than the 5 micron. Now if surrounding is very humid, then your volume of silica gel or size of breather will increase. Then again in the silica gel we have different type. Uh, then again size of beads of the silica gel. So after getting all these information, one can suggest the appropriate breather.
All right, thank you so much. We have a lot of questions yet that are not answered, but don't lose any hopes. We will reach out to you via an FAQ document, how we do every single time. We will answer all your questions and release a document and share the same via email, over LinkedIn, and over other different platforms that we have. Two things to share. One is we are doing this webinar to achieve the ultimate vision of zero mechanical breakdowns and how we are spreading awareness and educating people on different topics, bringing interesting topics. I would request all of you all to please take this survey and suggest us future topics that you would want the discussions to happen. Any particular topic or any particular issue, if you want the webinar to be more towards a specific industry, given your suggestions and feedback, we would love to read them and execute a lot of them. These all topics gets decided on how you take the survey and suggest us. We have our upcoming webinar on the 25th of November, exactly around a month from now. And we have a lot of festivals and festivities coming in between these two webinars. Make sure you take care of your family well, take care of your health well, and stay healthy and safe during such times. With respect to being into our community of lubrication professionals that we have a global community on different platforms. So I would like you to get in touch if you're interested to join these communities where you can learn, share, experience a lot of things around lubrication reliability and contamination control. We have a lot of industry experts from all across the world on the same platform. So stay updated, being in touch with us, and drop in an email with any situation or issue that might arise to you, or um, that has taken place in the past. And even if you would want to have a chance to get a platform to share your experiences with everyone, we are more than happy to welcome you and apply for the Google form that is shared with you all, and check out with us if you can be one of the speakers on our platform. Thank you so much for your time. We have had a great evening, Mr. Anshuman and Yogeshi. And thank you, lovely audience. Stay tuned with us. Until then, bye. Good night.
Thank you so much.
Thank
Bye-bye.
you.
Stay safe,
Bye
stay
bye.
healthy.